Hello, students. I'm going to walk you through a little mini lesson that is really good to do at the beginning of this unit. Now that you know all those things hanging from the ceiling in our classrooms are meant to represent stars, we can go on a little bit and learn something about those. So if you look at the title here, it's pretty clear we're going to be looking at a relationship that astronomers discovered over 100 years ago after collecting a lot of data on stars that were relatively close by. Astronomers started to realize there was a relationship between the mass of a star and its luminosity. Don't worry, we will go over these terms and you'll be a pro by the end. Before we go, I want to do a little review with you. I know that your middle school science teachers and your middle school math teachers did a really good job with you on some graphing terms. So just as a little bit of a reminder, we have two variables that we plot on a graph whenever we plot data for science, and they are called the independent variable and the dependent variable. Now, you might remember that the independent variable, sometimes we use IV as a shortcut, it's always plotted along the x-axis, and that's your horizontal axis. Whereas the dependent variable, aka dv, is plotted along the y-axis, and that's always your vertical one. Okay, hopefully that was quick and easy for you. But now we have to go into some science terms so that we can understand the slides that follow. First, we're going to talk about stellar luminosity. Okay, pretty easy. Stellar luminosity is simply the brightness of a star. Okay. Astronomers have the ability to measure how much light comes out of stars, and they can get some pretty big numbers when they do that. More on that in a little while. I'm going to explain to you a clever little trick that astronomers use to be able to express how bright a star is. It's pretty easy. Stellar mass, easy. The amount of matter a star contains, just like anything else that we do on Earth with masses. Okay. Now, a lot of times with both of these terms, astronomers will like to express that data or those properties of stars in solar units. And some of you might already know what this means, but if not, I'm going to tell you. It means that the values are expressed in suns. You might be like, what? What does that mean? Well, for example, if we say a star has a luminosity of 1.5 sols or suns, we're basically telling you that the star is as bright as 1.5 of our own suns. You would have to take our sun and another half of our sun and combine all that light to equal the light of a star that has 1.5 solar luminosities. Does this make sense? If not, rewind and try again, okay? Or check in with me tomorrow. And by the way, you got to love astronomers. They try so hard to make everything easy for us because they know the field of astronomy can be very complicated. So they use this cute little symbol, right? It looks like a circle with a dot in the middle of it. And in astronomy, that means sol, or the sun. So for example, if you ever see me write on the board something like this, where I say a star's mass is 3 and then I follow it with that symbol, you ought to know that I mean that the star has a mass that is 3 times that of our sun. Okay? If I were you, I would take a moment, I would pause this video, and I would go ahead and write this in my notebook. And if I have to, I would write it in a way that I can understand it. Maybe you don't like the words I used. Maybe you can write it in your own vocabulary, as long as you understand the concept. Okay, so let's get into graphing. All right, so we are putting stellar mass along which axis is that? The x-axis. And we're putting luminosity along the y-axis. And both of these are being expressed or are expressed in solar units. Now, we're going to use this opportunity to talk about titling our graphs. This is something that we push our freshmen to figure out early on in their high school career so that by the time you're a sophomore, this is easy breezy. Now, there are different opinions on this, and I'm going to be very frank with you. There are a couple of teachers here in this department who like teaching students to use the y versus x formula, and some of you might have used that in middle school. And then there are some other teachers, like myself, who prefer a slightly different one, and that is y as a function of x. The feedback we are getting is that students don't necessarily know what it means when they're saying y as a function of x. But I know that that's aligning well with your math teachers. I think they use that formula. And so it's I think the more you use it, the more you'll start to understand exactly what it means. So what does it mean when I say to you, I want you to try to create your titles with the formula y as a function of x? Well, it's pretty easy once you understand what to do. You just insert for your y, okay? You just insert the language for your dependent variable, your y-axis. So what is the label for your y-axis here? Well, it's luminosity. And what is the label for your x-axis here? It's stellar mass. So that would mean, watch this. A good title would be Luminosity as a function of a star's mass. See how easy that is? Piece of cake, right? All right, we'll practice more of that as we move on into other graphing exercises throughout the year. Okay, we're going to go ahead, we're going to plot. But as you guys are starting to get to know me, you're going to see that I like to throw questions at you a lot and make you think before I throw the answer up in the air. Okay, so I really, really need you to do this. I need you to pause the video, and I need you to ask yourself, if we go ahead and plot the sun on this graph, where is it going to be? Now, you might be thinking to yourself, Mr. Luzetti, how the heck do we know? We don't even know what the mass of our sun is. We don't even know how bright the sun is. Oh, yes, you do. Because look, I'm asking you to express these in solar units. So how massive is our sun if we express our sun's mass in suns? Here's a hint. It's painfully easy. And how bright is our sun if we express it in suns? Again, this is easy. I'm going to give you a 5, 4, 3, 2, 1. Ta-da! Hopefully some of you knew it was there. Look, let's think about that data point for a minute. What is the x value? What is the value along the x-axis there? 1. It's right on that 1 line. So this should make sense. We're talking about our sun. And what's the mass of our sun in solar units? 1, right? And what about its luminosity? How bright is our sun if we express it in suns? Well, it's 1. And if you look, if you extrapolate over, I think that's the right word. If you look over here, it would land at the value that corresponds to 1. And this makes sense. Our sun has a brightness of 1 solar, right? Okay. Now, what is another data point we can probably throw on here without even looking up data of stars? I'm wondering if any of you are thinking this one. 0 is 0. This makes sense if you think about this. If you have a star, let's imagine we have a star and we're shrinking it, we're taking more and more mass out of it. Eventually, we're going to get to a point where we don't even have a star anymore, right? We're going to have nothing. And if you don't have a star, you don't have any light coming out of it. So that would make sense. 0, 0 is a real true data point on this graph. Now we're going to go ahead and we're going to plot some more. Bam. Bam. It looks like these are right on that x-axis, but if you look real carefully and use your eagle eyes, you're going to see that these values are starting to climb up a little bit along that y-axis. In other words, let's compare this one with this one. Well, the latter one, the second one I'm highlighting here, is a little bit higher on this graph than this one is. So these aren't just, staying on that 0 line for the x-axis. They're climbing up. All right, and now we have another one. And now's a good time to stop for a minute and ask yourself this question. Go ahead and read it. All right. So are these data points starting to reveal to us that the relationship between a star's luminosity and mass, is it linear? Can you connect this with a straight line? Or is it something not linear where we'd have to use a curve? Which do you think it is? Let's see if some more data points can really make it clear for us. Aha. Hopefully, you're recognizing what I'm recognizing, and that is that this is definitely not a linear relationship. We cannot draw one straight line to connect all these dots, so therefore it is not linear. Okay, go a little further, and this is starting to show us that there is an exponential relationship between a star's mass and its luminosity. Some of you know what that means when I say that. Some of you don't, so I'll try to explain it a little bit. When we say that this relationship is exponential, it's because, look, as our x values increase, right? So we're going up by 0.2 every time, right? So that's a very steady climb, 0.2 higher every time. But as we are doing that, what's happening to our y values? Well, look, over here, we hardly get a climb at all in our y value, right? In the beginning, our y doesn't seem to be growing much, but then we start to see a situation where, wow, these y values are starting to jump higher and higher each time, okay? So we are saying that as the x value increases, the y value increases at an ever increasing rate. Okay. All right. Let's go here now. So I did this last year with my students, and I want to let you all know that if I taught it at many other high schools across the country, I probably wouldn't take it this far. But I'm a proud teacher at Joe Barlow High School, and I know that I have a lot of very studious academic students who like to push themselves. And so we're going to go there. And you can do this. And I know you can do this because I did it last year, and some of my students were able to figure it out. And let me be very frank here. Even if you try and you don't get the answer correct, you still win. Because when you push your brain to try to figure out some things that are a little tough for you, you get more intelligent. And you guys are gonna get sick of hearing it from me, but I use this metaphor all the time. Folks, when I go to the gym at night, I'm going there to try to get healthy and maybe build up some muscle mass and train my heart to be more cardiovascularly fit, right? Well, do I get to go to the gym and watch people on the treadmill? Do I get to go to the gym and watch somebody working out? No, I got to pick up those weights myself. I gotta do the weightlifting. I've got to get on the treadmill. Otherwise, my body is not going to improve. And the same is true for your brain. You got to try to push through some of these things. And even if you don't reach your goal by the end of the lesson, you still have gained something. I promise you on that. So I'm going to give you a hint, okay? So what we're trying to do here is we're trying to figure out, okay, we have a graphical display here. We have a graphical display of two properties of a lot of stars, okay? Luminosity and mass for a lot of stars. This is just graphical though right now. We want to see if we can turn this into a mathematical formula, okay? See if we can discover what is the underlying mathematics that the universe has for these stars. There is some sort of mathematical relationship that connects a star's mass to its luminosity, and we are going to try to be detectives and figure that out. So here's the hint. Pick an easy data point. So I'm saying go ahead and pick this one here, well, I can't highlight it because it's a locked image. But anyway, you can see where my cursor is hovering. Okay, so that data point there has an x value of 2. Okay, so a stellar mass of 2 solar, and a y value of 16. So a luminosity of 16 solar, right? That's why I'm showing 2, 16. That represents that data point. All right. And ask yourself, what do I have to do to that x value to get it to equal the y value? Well, I could say to myself, well, gee, I know that 2 times 8 equals 16. So I feel like maybe I might know the answer. It might, the mathematical relationship just might be you take your x value and you multiply it by 8 and voila, you have your y. But you can't stop there. You have to check yourself, okay? And so then it says here, then see if that same formula also works for other data points. It has to if it's the right formula. If it doesn't work for other data points, then you're not onto it yet. So let's go ahead. Let's look at the value of 1, 1 right here. That's this one here, right? Well, if I multiply 1 times 8, I don't get 1, I get 8. So, that means that it can't be as simple as just multiplying the x value by 8. It's something else. It's going to be a little more complicated. I really think some of you can do it. And I want to see you come into class really happy because you've figured it out, or at least you've tried. Okay? And I will reveal the answer another day. Take care.